Hello children, welcome to the YouTube live class of Standard 10. Today we are going to learn Unit 2 Optics, the remaining topics in this lesson. Okay, in the last class we have discussed about what we have discussed. We have discussed about the scattering of light, then what is the properties of light, the refraction of light, then the refraction of a composite light, the dispersion of light. Okay, yes. So today we are going to learn about the lenses. Okay, so lenses. So this class we are going to start with the lenses. Okay, what is mean by lenses? How the lenses are formed? Where we are using the lenses? Yes, lenses are used in the cameras, in the magnifying glasses, okay, and in the mirrors, okay, to enlarge the images we are using. This lenses, okay, the convex lenses we are using in the cameras and the magnifying glasses. Is it? Yes. The lenses. A lens is an optically transparent medium. So what is lens? A lens is an optically transparent medium bounded by two spherical refracting surfaces. So on one plane and one spherical surfaces. So what is lens? Lens is an optically transparent medium. Optically transparent medium means it can transfer the light from one side to another. It's transparent. Okay, as you already told, you know the three types of the object, which is transparent, translucent, and the opaque. Okay, so here a lens is a transparent medium. Okay, what is lens? Lens is transparent medium which allows the light to pass through it. Okay, so what happens if the light passes through the lens? It is reflecting, the light gets reflected or refracted. Yes, it gets refracted. Why? Because the light from the air is going through the lens. Lens is actually made of glass. Is it? Yes. So the light is traveling from rarer medium to the denser medium. Okay, how the light is traveling from the rarer medium to the denser medium. So what happens if the light passes through the rarer medium to the denser medium? It will get refracted. Is it? It will get refract. Okay, not reflect. It refract. Okay? Yes. So what's happening in the light? When the light passes through the lens, it gets refracted, not reflection. Okay? Because the light is traveling from the air to the glass. That means from rarer medium to the denser medium. Okay? So lens is actually a transparent medium. Then it's bounded by two spherical refracting surfaces. It's actually bounded by two spherical refracting surfaces. Okay? See how actually there's two types of lenses. Okay, the types of lenses are there. But here in this class we are going to discuss about the convex and concave lens. Okay? So generally how the lens is formed? By the two spherical surfaces. By the two spherical surfaces. See for example. Okay, so before that we will discuss about the convex and concave lenses. Okay? Yes. So convex or biconvex lenses. So lens is basically classified into two types. One is convex lens and another one is concave lens. So convex or biconvex lens. So we can say that it's convex or biconvex. So why we are saying that we will discuss. Okay? It is a lens bounded by two spherical surfaces such that is thicker at the center than at the edges. A beam of light passing through it is converging to a point. So a convex lens is also called as converging lens. Okay? So convex lens, otherwise known as. So there are two types of lenses, convex lens and concave lens. Concave lens, convex lens, otherwise known as converging lens. What is convex lens otherwise known as? It is convex diverge. It's scattered the light. So here the light seems to be diverged. Okay? Yes. So that we will discuss. Okay? See, actually convex lens is a lens bounded by two spherical surfaces. Okay? Two spherical surfaces. What is the shape of the convex lens? Two spherical surfaces. Okay? That means like this. Okay? Yes. So how it is made? See. This convex lens is actually a part of a spherical mirror. Is it? Is it or not? See, if we cut this part and this part, making this convex lens. Okay? See? The curved surface. So here it's curved inward. This one is curved outward. So two spherical surfaces are making the convex lens. Okay? Yes. So here the spherical lenses curve outward. Okay, so here the surface, the spherical surface is curved outward. Curved outward. Is it or not? See, I took the two parts. The convex lens is actually it's a part of the spherical mirror. Okay, it's part of the spherical mirror. Two parts of the spherical mirror making a convex lens. Okay, this side and this side. Okay, yes. So, what about the shape of the convex lens? It is, the center is thicker, the center is thick. And what about the edge? It is thin. Okay? Yes. So, two spherical surfaces does that it is thicker at the center than at the edges. Then at the edges is thicker at the center. Okay? Yes. So convex lens also called as converging lens. So next we are going to learn the concave lens. How the concave lens is made? It is also by the spherical mirror. Okay? Then now I am using the same spherical mirror to make the convex lens. So what is the shape of the convex lens? Okay. Here, this time, this curved part of the surface mirror is curved outward. Is it? Is it or not? The spherical lens is curved inward. So here, this spherical mirror, the curved part of the spherical mirror is curved inward in the lenses. Okay? So in the quadrant, joint one, that is concave lens. Okay, this is concave lens and this is convex lens. So what about the shape of the concave lens? It is lens bounded by two spherical lenses such that it is thinner at the center. It is thinner at the center and thicker at the edges. Okay, so spherical lenses, if the spherical lenses curve outward, if the spherical lenses curve outward, that means the spherical surface of this mirror is curved outward. Okay, if the spherical surface curved outward, that is convex lens. If the spherical lenses curve inward, that is concave lens. Okay. Next we are going to learn about the other type of lenses. So other type of lenses are also there, the plano-convex lens. So here, if one of the faces of biconvex lens is plane, okay, so here this convex lens otherwise known as biconvex lens because it's actually made up of the two spherical sides. Part of perpendicular. So biconvex lens. Okay, otherwise we can say it as biconvex lens. So this this side one side convex. So two sides of two spherical surface we are using here. So this biconvex lens. So here also it is biconcave lens. Okay? Yes. So and what is mean by plano-convex lens? Plano-convex lens means if one of the faces of a biconvex lens is plane. Okay? So here one face of the biconvex lens is plane, then it is called biconcave lens. Sorry, plano-convex lens. Okay? It's plano-convex lens. Okay, then plano-concave lens the same. So if one face of the concave lens is plane, then it is plano-convex lens. Okay, so these are about the convex and concave lenses. So the concave and convex lenses is a part of the spherical mirror. Okay, part of the two parts of the spherical mirror are making the concave and the convex lenses. Okay, so if the spherical lenses are curved outward, okay, if the spherical surface is curved outward, then it is called convex lens. If the surface is curved inward, if the lens is curved inward, then it is called concave lenses. Okay? Yes. Yes. Next we are going to learn the image is formed due to refraction through a convex and concave lenses. So how the images are formed after the refraction of light through the convex lens. Okay, see here. So before that we need to know the three rules. Okay, the three rules in that. So when an object is placed in front of a lens, the light rays from the object fall on the lens. The position, size and nature of the images formed can be understood only if we know the basic certain rules. Okay, yes. When an object is placed in front of the lens, the light rays from the object fall on the lens. Okay, so after it falls, what happens? It gets refracted. So after refraction, where the image is formed, what about the size of the image? What is its nature? Okay, and where the image is formed. Okay, so for that, to know that, we need to follow the rules. So what are the three rules we have? The rule 1. The rule 1, when a ray of light strikes through the convex or concave lens as its optical center, it continues to follow its path without any deviation. The first thing is, see, before that we need to know some terms in drawing the ray diagram. Is it? Yes. So listen, we already know the spherical mirror. This is a spherical mirror. C. Okay, this is a spherical mirror. So in a convex is making of convex lens, the two. So if the two part of the spherical mirror is making the convex lens, is it? Yes. So the curved outward, the two part of the spherical mirror. Okay. So here in the spherical mirror, what is the center of curvature? So the principal axis is passing through the spherical mirror. Okay, so and here this is the O, that means the center of the spherical mirror. Okay, and what is the center of spherical mirror? Otherwise, it is, we can call it as center of curvature, C. Okay, that is center of curvature. Next we have the pole. Okay, what we have? We have the pole. Yes. Center of curvature. What is center of curvature? It is the center of the sphere from which the mirror is made. Okay, it is the center of curvature. C is nothing but is the center of curvature, is the center of the sphere from which the mirror is made. Okay, the mirror is center point. A spherical mirror. Okay, yes, it is denoted by the letter C, and it is denoted by the letter C. Okay, then so next we have the pole. Okay, the other time the pole here, the pole is nothing but, okay, the distance between the pole is nothing but the focal distance between the center of curvature and the vertex or the pole. Okay, the pole is nothing but it is the geometrical center of the spherical mirror. Okay, see here, this is the geometrical center. For this side, this is the center, and for this side, this is the center. So these are the poles of the mirror. Okay, these are the poles of the mirror. The center of the spherical mirror. Okay, the geometrical center of the spherical mirror. Then the radius of curvature. Next the important thing we have to learn. The radius of curvature, it is the distance between the center of the sphere and the vertex. Okay, so what is radius of curvature? It is the distance between the center of the sphere and the curvature. Okay, it is the distance between the center and the curvature. It is the distance between the center of the sphere and the curvature or the vertex. Okay, vertex. Okay, yes, so that is F. What it is the radius of curvature. This is radius of curvature. Yes, and it is denoted by R. Sorry, it is R. And it is denoted by R. Yes. Next, principal axis. Next we have the principal axis. When a beam of light, the line joining the pole and the mirror and its center of curvature is called the principal axis. So what is the principal axis? The line of joining the pole of the mirror and the center of curvature. The line which is joining the center of curvature and the pole at the each side. This is the principal axis. What is this? This is the principal axis. And this one is the center of curvature. Center of curvature is nothing but is the center of the spherical mirror. Center of curvature, the center of the sphere. Okay? Yes. Next what we have? We have the focus. When a beam of light is incident on a spherical mirror, the reflected ray converges or appear to diverge from the point is the principal axis. This point is called as the focus or principal focus. It is known as the focal point. It is denoted by the letter F in the ray diagram. Okay, in ray diagram it is denoted by F. Okay, yes. Next, then the focal length. The focal length is nothing but the distance between the pole and the principal focus. Okay, focal length. Next, so there is a relationship between the focal length of a spherical mirror and its radius. What is that? The focal length is equals to important formula. Focal length is equals to radius of curvature by 2. Radius of curvature by 2. Okay. Same. The 2 into F, that means the focal length is denoted by F, is equals to radius of curvature. Okay? Yes. So what are the terms are followed in the spherical mirror. So the first one, the center of curvature, that means the C. The C is nothing but is the center of the sphere from which the mirror is made. Okay, see the from which the mirror. So if this is the mirror, so C is the center of the sphere, then P is the pole. Okay, pole is nothing but is the center of the spherical mirror. Okay, the center of the spherical mirror, and C is the center of the sphere, and P is the center of the spherical mirror. Then we have the radius of curvature. The radius of curvature is nothing but it is the distance between the center of the sphere and the vertex. Okay, this is the radius of curvature. The distance between C and P. That is radius of curvature. That is R. Okay, then the principal axis. The principal axis is nothing but the line which is joining the pole and the C. Okay, the pole and the center of curvature is the principal axis. Okay, next we have the focus. The focus is nothing but, so when a beam of light is incident on a spherical mirror, the reflected rays converge at or appear to diverge from a point of the principal axis. That point is called as focus. Okay, another beam of light. When a beam of light is incident on a spherical mirror, after refracting, where they are converging or where they are converging and where they are diverging. Okay, that point is called as focus. Okay, that is focus. Then the focal length. The focal length is the distance between the pole and the principal focus. The pole and the principal focus, that means the focal length. So it's called as the focal length of a spherical mirror. So here there is a relationship between the focal length of a spherical mirror and its radius of curvature. Okay, there is a relation between the focal length of a spherical mirror and the radius of curvature. So that is, the focal length is equals to radius of curvature by 2. Is it? So this is the focal length. Radius of curvature by 2. So R by 2 is making a focal length. Okay. This is actually focal length. Okay. So that is a relationship between the two. The focal length and the radius of curvature. The focal length is actually R by 2 is equals to. So this is actually F, the focal length. This is equals to R by 2. Is it? This side of R we have, and another side also we have an R. Okay, so R by 2. So focal length is equal to, F is equals to R by 2. Okay, that means radius of curvature. So the distance between the pole and the principal focus is called the focal length. The distance between the pole and the principal focus is called as the focal length. The focal length is actually the half of its radius of curvature. Okay, half of its radius of curvature. This line fully is called as F. Okay, so the half of the radius of curvature is equal to the focal length. Next, so this is the basic of the ray diagram. Okay, see, so while we write the ray diagram, so we have to follow these terms as the first one. This is the lens. Okay, the lens here it has it is actually a part of a spherical mirror, okay, which is curved outward. Okay, so this is the line which is part, this is the principal axis. The principal axis is nothing but which is joining the center of curvature and the pole. Is it or not? The center of curvature and the pole which is joining. So this is the principal axis. Okay, so here what are the points I must notice here? I must put here. This is O. the center point of this lens. Okay. Next we have the F1 and F2. Okay, the focus point. Okay, F1 and F2. Okay, the focus point which is converging or diverging the light. The point which is diverging or converging the light. Okay, F1 and F2. Okay, yes. So what is the first one is telling us? When a ray of light strikes the convex or convex lens, as its optical center, it continues to follow its path without any deviation. That means, if when a ray strikes on the convex or convex lens through the optical center, so this is the optical center of the lens. O, the center of the lens. Okay. So when a ray, if a ray passes through, when the ray from one ray of light, here we are taking one ray, okay, one ray of the light. When a ray passes through the O, that means the center, the optical center, how it will behave? See, it continues to follow its path without any deviation. Okay, see, we know that when the light passes through the lens, it should be refracted. But if the ray passes through the center of the lens, there will not be any deviation. Adina nendu deviate agama light enna pannum endha edutha adu refract aagum adhe path endha edutha adu incident aagum adhe path da refract aagum. Okay, then there must not be any deviation. Okay, that is rule 1. Next, what's the rule 2 is telling us? This is what happens in the converging lens, that means in the concave lens. So the concave lens also the same thing is happening. The principal axis, the center of the optical center, then this one is the focal point, F1 for this side and this one and another F2. So why we are putting the F1 and F2? Because see here, the two focus point we have, is it? This is the center of curvature. Okay, if we cut the spherical mirror into two, so here I have the center of curvature, the principal axis, the radius of curvature and the focus point. Is it? The F. So this side one F I will have and that side also one F I will have. Is it or not? The focus point. Okay, so that F1 and F2. Okay, so here, so same thing, if the ray passes through the center of curvature, the incident ray, after it refracting, its path doesn't change. Okay, after refraction, it doesn't deviate from its path. Okay, so this is what happened if the ray, or light ray, the lens order, optical center valiya pochuna enna agum and the light deviate agadu endha valiya adu vandadho adhe valiya na povom adhe valiya da refract agum. Okay, this is rule 1. And what about the rule 2? This is rule 1. And what about the rule 2? When the rays parallel to the principal axis strikes a convex or concave lens, the refracted ray or converge. That means in convex lens, the refracted ray or converge or appear to diverge from. That means in the concave lens is diverge the principal focus. Okay, so here this is the lens, concave, convex lens. The rule 2, what happens? Convex lens, the optical center, the focus, F1 and F2. Okay, so in this type. The second type, when a parallel ray to the principal axis. See, our ray which is parallel. So this ray is actually parallel to the principal axis. Okay, when they passes through the lens, what happens? Its refracted rays are converged. See, listen, it passes through the focus. Okay, when the ray is parallel to the principal axis, after refraction, it passes through the focus point. Okay, yes, it's converging at a point. See what happens in the concave lens? The same ray which is parallel to the principal axis, the center of the lens F1 and F2. Okay, a parallel ray which is parallel to the principal axis. After striking, see where it should be. It should strike on the center of the lens. Okay, so after it gets refracted, it passes to the F2. Okay, here is actually in the concave lens, it's diverging. Okay, if we extend the lines backward to where it meets, it meets at the F1. Okay, in the case of concave lens, in the case of refraction in concave lens, after diverging, the divergent ray should be extended backward. Okay, so where it forms, where the image is formed? Here at the F1. Okay, it's diverging. Okay, next. Rule 3. When a ray passing through or directed towards the principal focus strikes a convex or concave lens, the refracted ray will be parallel to the principal axis. What happens this time? See, in rule 1, when the ray passes through the optical center, that means the optical center of the lens, what happens? It doesn't deviate. Okay? And what about in the rule 2? When the ray passes, when the ray which is parallel to the principal axis passes to the lens, convex lens, after refraction it gets converging through the focus. Okay, in the concave lens also it's same happening. Okay, and what about in the rule 3? Rule 3, this time when a ray passing through or directed towards the principal axis, principal focus, strikes the convex or convex lens, the refracted ray will be parallel to the principal axis. So this time, if the ray passes through the F, okay, F1 and F2, okay, if the ray passes through the focus, what happens? After it gets refract, again it gets parallel to the principal axis. See here, a ray which is passing through the focus, after refraction, it goes parallel to the principal axis. Okay, and so that's what it's saying. So here in the concave lens, what happens? The concave lens, this is O. Okay, this time the rays passes to the focus. So what happens here? Yes. It passes to the focus. after deviation, where focused on the F2. Okay? Yes. So when a ray passing through or directed towards the principal axis, principal focus, strikes a convex or concave lens, the refracted ray will be parallel to the principal axis. Okay, the refracted ray is parallel to the principal axis. Okay? Yes. Next, the refraction through convex lens. So, first, what are the three rules we have? The first rule, that means when a ray of light strikes the convex or concave lens at its optical center, it continues to follow its path without any deviation. Okay, without any deviation, it continues its path. Okay, citizen. The rule 1 and rule 2. What is the rule 1 is telling that? Okay, this optical center of the, this is optical center of the lens. Okay, then see the F1 and F2. The focus point. Okay, the first rule is the ray which is falling through the, this is actually the incident ray. The incident ray which is falling to the optical center is not deviated. That deviate refract out. That is the rule 1. And what about the rule 2? If the light ray is parallel to the principal axis, okay, the incident ray which is falling on the lens, after it gets refracted, what it is doing is flowing to the focus point. Okay, it's refracted to focus point. Okay, next, what's the third point? If the incident ray is false, if the incident ray goes to the focus point after refracting by the lens, again the refracted ray is parallel to the principal axis. See, one ray which is passing to the optical center. Optical center valiya or ray pogumbodhu adu valiya da thirumbi adu refract agum. Okay, adutha rule enna soludhu? A ray which is passing, the ray which is parallel to the principal axis. This is the principal axis and this ray is parallel to the principal axis. Andha mari irukumbodhu enna agudhu? After refraction, the refracted ray passes to the F2. Okay, it's converging at F. Okay, and what about if the ray passes to the F, the focus point after it refracted, again the refracted ray is parallel to the principal axis. Okay, this is vice versa. See, the principal axis, the parallel ray which is fall on the lens, after refraction it goes to F. Okay, if the incident ray goes to the F, okay, which is fall on the F, after refraction it goes parallel to the principal axis. Okay, so these are the three rules. Okay, so by using this we are going to construct the refraction of light through convex lens. Okay, yes. So the convex lens, the image formation by convex, and we are going to discuss about how the image is formed in the convex lenses. Okay, the first one, if the object is at infinity, see, if this is the convex lens, okay, the center of the lens is out. Okay, then the F1 and F2, the focus point F1 and F2. Okay, again 2f1. 2f1 is nothing but what? F1 is the radius of curvature. See, this is A. It's the radius of curvature. That's 2f1. That's 2 into f. That's it. 2 into f is equal to the radius of curvature. Okay, if we double this, okay, we will get. For example, if the f value is 2 centimeter, what about the 2f1? It will be 4 centimeter. Okay? Yes, this side also is, if I take that at 2 centimeter, and it should also be at 4 centimeter. Okay, if the value of the f is 2 centimeter, the 2f1 is 4 centimeter. Okay? Yes. So, radius of curvature. Okay, next. So, when an object is placed at infinity, a real image is formed at the principal axis. The size of the image is smaller than that of the object. So, what happens? See here, if the object is at infinity, okay, is infinity. If the object is at infinity, that means number one object ரொம்ப தூரத்துல வைக்கும்போது என்னாகும்? What about the rays falling on the lens? See, all the rays are parallel. Okay? If the object is at infinity, ரொம்ப தூரத்துல வைக்கும்போது the rays, all the rays are parallel to the lens. So at that time what happens? After it gets reflects, what happens? It focus is converged at the point F. Okay? So here in this place the image is formed. Okay, the image here formed is diminished. Is it? The size of the image is small. Okay? Yes. So when an object is placed at infinity, a real image is formed at the principal focus. Where it formed at the principal focus. Okay? Yes. Principal focus. So the size of the image is much smaller than of the object. Okay? The size of the image. This is the object. The object is nothing but which we are keeping before the lens. Okay, the image is formed. After the refraction of this light, we will get the image. Okay, the image where it is formed, it is actually in the focus. So here the image formed, you see the size of the image is very small. It's small in size. Okay, yes. So if we keep the object at infinity, what about the size of the image? Okay, the object at infinity. The first case is the object at infinity. That means the object lens ரொம்ப தொலைவில் இருக்கும்போது எப்படி இருக்கும்? உருவாக்குற image கண்டிப்பா எப்படி இருக்கும்? ரொம்ப சின்னதாக இருக்கும். Okay? Yes. So, what is the type of the image form? Is a real image. Okay, and what of the size of the image? It's small in size. It's diminished. Otherwise, you can say that it's diminished. Diminished means small size. Okay. Yes. Next, the object placed beyond C. That means beyond C. Here, what is C? The next case. See, the principal axis. The principal axis. This is O, the optical center of the lens. Okay, this is the F1 of this C. In the curved surface, okay, the F1, this one is the F1. In the curved surface, which is the focus point? This one is the focus point. Okay, so this is F1 and this we will take it as F2. Clear? is F1 and F2. And the 2F1, the 2F2, and this also, this side is 2F1. Okay, yes. The 2F1 is nothing but is the radius of curvature. Okay, the radius of curvature is 2F. Yeah, see here in the spherical mirror. This is the radius of curvature. Okay, the radius of curvature is equals to 2 into F. We already said that focal length is equals to, that means this F, this full F. Okay, this focal length is equals to radius of curvature by 2. Okay, so F is equals to R by 2. Okay, if so the 2F is nothing but the radius of curvature. Okay, the 2F. So otherwise it is known as C. Yeah, 2F is actually the center of curvature. Okay? Yes. So when an object is placed behind the center of the curvature, behind the center of curvature, okay, behind the center of curvature, this is actually the center of curvature. The 2F2 is the center of curvature, rather the spherical or the center point area. Okay, see here. This is the center point of the spherical mirror. So center of curvature. This one is the 2F2 is the center of curvature. So okay, 2F2 is C here. Okay, so object placed beyond C. Okay, if I keep the object, so here this side. So where I am going to keep the object at the left hand side. Okay, the object is at the left hand side. After the object passes, the rays from the object passes to the lens, it gets refracted. Okay, so enter your object at the left hand side. Okay, this time the object is placed beyond C. Beyond C. Okay, so beyond C means this is C. Okay, 2F or C. So beyond C. So what happens this time when I keep the object beyond C? Okay, the two rays I am taking here. When an object is placed behind the center of curvature, that is beyond C, behind the center of curvature of the spherical mirror, what happens? A real and inverted image is formed between the center of the curvature and the principal axis. See here, one ray from the head, okay? After it gets refracted, where it passes through, passes through the F2. There are two rays I am taking. One ray which is parallel to the principal axis, and another ray which is flowing to the optical center. Okay? Yes. What happens? After it's refracted, okay, the two rays, okay, so where the image will form, okay, after the refraction, so in the refracted rays வந்து எந்த இடத்துல கன்வர்ஜ் ஆகும், எந்த இடத்துல மீட் ஆகுதோ அங்க என்ன பண்ணும், image form ஆகும். Okay, where in upside direction. Okay, தலைகீழான image எங்க இருக்கும், the two images, the refracted incident ray, the refracted rays எந்த இடத்துல குவியுதோ, எந்த இடத்துல ரெண்டும் intersect ஆகுதோ அங்க தான் என்ன ஆகும், image form ஆகும். Okay, so this object, so when the object is beyond C, when an object is beyond C, what happens, where the image is formed in between, where it formed in between the center of the curvature and the principal axis. Okay, yes, that is from between 2F2 and F2. Okay, in between 2F2 and F2 the image is formed. And what about the type of image here? A real and inverted image is formed. Okay, so here this is the real image refracted ray வந்து எந்த இடத்துல ரெண்டும் மீட் பண்ணும்போது அந்த இடத்துல தான் இமேஜ் உருவாகும். So that is the real image. So this image is actually formed by the intersection of the refracted ray. So அந்த மாதிரியான image என்ன சொல்லுவோம்? Real image. And what about the real image is always inverted. Inverted னா தலைகீழான image கிடைக்கும். Okay, so real image, inverted image. And what about the size of the image? Is smaller than the object. So here, look at the size of this object and the image is formed is smaller. Okay, so the size of the image is smaller than the object. Okay, so this is the image formed after it gets refracted. எப்படி அதாவது first case ல நம்ம என்ன பண்ணுவோம், ஆப்ஜெக்ட் என்ன பண்ணுவோம், இந்த 2f, that means the center of curvature க்கு ரொம்ப தூரமா வெச்சோம்னா, லென்ஸோட center of curvature தூரமா வெச்சோம்னா என்ன ஆகுது, எல்லா ரேஸஸும் இன்ஃபினிட்டி, அதாவது ரொம்ப தொலைவுல வைக்கும்போது எல்லா ரேஸும் போய் என்ன ஆகுது, parallel all the rays are, so all the rays, the incident ray, all are parallel to the principal axis and they are converging at the f focus point போய் converge ஆகுது. So ரொம்ப சின்ன image நமக்கு கிடைக்கும். Then what about if the object is placed beyond c? Beyond c, c க்கு ரொம்ப தூரமா வைக்கும்போது என்ன ஆகுது, what happens, the ray, so here the two rays I took, one ray which is parallel to the principal axis and one ray which is falling to the optical center. Okay, see, so after it's refracted, what happens, the 2 points, the refracted rays are converging at a point, they are intersecting at a point. Okay, அந்த பாயிண்ட்ல தான் என்ன ஆகும், எந்த இடத்துல இந்த ரெண்டு ரேவும் intersect ஆகுதோ அந்த இடத்துல தான் எந்த இடத்துல இந்த refracted ray ரெண்டும் intersect ஆகுதோ அங்க தான் என்ன ஆகும், image form ஆகும். So form ஆன image எப்படி இருக்குது, it is inverted image, it's upside down side image, and it is real image. So real image means here this image is formed by the interaction, by the intersection of the two refracted rays. So refracted ray into intersect ஆகும் about the image is real image. And what about the size of the image it formed? It's smaller than the object. And where it is formed? It's formed in between the two f2 and the f2. Okay, it's between the center of curvature and the focus. Okay, the principal focus. Okay, so here the f is the principal focus and this one is the center of curvature. Okay, the principal focus and the center of curvature. Okay, next, what's the next case? If the object is placed at c. Okay, now I am going to take the object at c, அதாவது at the center of curvature ல வைக்கும்போது என்ன ஆகுது, what happens, okay, the third case, now I am keeping the object at the center c, at the center of curvature at c. Okay, so this is the lens. Okay, the optical center of this lens. This is the principal axis. Okay, then the principal focus f1 and f2. This side is f1 and f2, and I have the center of curvature. Okay, the center of curvature c. That is 2f2. Then this side also is 2f2. Okay, yes. Okay, what happens this time? This time I am going to keep the object at c. So the 2f is otherwise known as c. The f is the principal focus. Okay. So here I am going to keep the object at c. 2f or at c. So what happens this time? Okay. See, there are number of rays are passing to the lens. Okay, but here we are going to take only the two rays for our convenience. Okay. Okay. So here. And one ray which is parallel to the principal axis, and another ray is passing to the center of curvature, optical center O. Okay, so here what happens after refraction? What happens? It gets refracted here, and after refracting, where they are meeting at F itself. Okay? See, where the image is formed after they get refracted, the image is formed at the 2F2, at the 2F of the other center, in the center of curvature. See, when an object is placed at the center of curvature, a real and inverted image is formed at on the other side of the center of curvature. Okay, so in the center of curvature, next side, the other center of curvature, another image form. Okay, what about the size of the object's image here? Is the same size of the object. Okay. So in the mari namu object because center of curvature வைக்கும்போது கிடைக்கிற image ஓட size எப்படி இருக்கும்? அந்த object ஓட same size ல இருக்கும். Okay, so here the image is formed. The image formed is actually, it's also a given image. Okay, see, கண்டிப்பா நீங்க ரே டயக்ராம் வரையும்போது என்ன பண்ணுவோம்? இந்த 2 rays எங்க intersect ஆகுதோ அங்க தான் image வரையணும். Okay, yes. Then here also there must be bending. எங்க bending பண்ணுவோம்? Here in the center. Okay, so here actually the incident ray is actually refracting. It's deviated. Okay, for example, this is a normal point. It's actually deviated. The speed of light is reduced. Okay, when it hits the lens. So that's what the path of the light is deviated. Okay. Okay, so here the image we got is real image. Okay, and it is inverted. Real image, inverted image, and what about the size of the image is formed? The same size as object. It's same size of the object. Okay, yes, this is in the case B. And what about if the object is placed between F and C? So what happens if we place the object F and C? That means the F and C. Okay, so this time I'm going to put the object where between this time the object is at the object placed between F and C. F and C, that means this is C and this is F. So in between I am going to take this place the object. This time what happens? Again a one ray parallel to the principal axis. Okay. And another ray which is passes to the optical center. Okay. Yes. So this time what happens? So here also the F2, it passes to the principal axis. Here I am showing you the principal axis, that is parallel axis. Parallel rays kandipa enna after refraction it goes to the principal axis. So refract aayadhu appo enna to the principal axis valiya, so principal focus valiya. This is the principal focus and this is the where the image is formed. So at a point, the two rays are meeting here. Okay, at this intersection, we have the image. Okay, so here look at the size of the image it formed. Okay, the image is formed at the right hand side of yours. Okay, okay, so here what is the image is formed? What type of image is formed? So here also the real image is formed and the inverted, the image formed is inverted. Okay, and is formed behind the center of curvature. Is it? And where the image is formed? It's formed behind the center of curvature. Okay, center of curvature. Yeah, see. 2F is nothing but is the center of curvature. F is nothing but is the principal focus. Okay, the focus point. Okay, yes. So here the image is formed. The image is formed is real and it is inverted. And what about the size of the image formed? It is actually, when compared to the object, the size of the object, the size of the image is bigger. Is it? Yes. So the size of the image is bigger than the object. Is bigger than the object. Okay. Yes. Okay. So the next case, the object placed at the principal focus. So this time I am going to keep the object at this F. Okay? Yes. The principal focus. O. Principal axis. Then the F1. This one is F2. Okay? Then 2F1 and 2F2. This time I am going to keep the object at the focus, principal focus. Okay, F is nothing but the principal focus. 2F is nothing but the center of curvature. Okay, yes. Okay, what happens? Again, the parallel, one ray which is parallel to the principal axis. Okay, which is falling on the lens and refracted and goes to the F2 and goes to the F2. Okay, and another ray which is falling on the center of curvature, sorry, so optical center is refracted. What happens this time? Okay, can we see any intersection of these refracted rays? Here the refracted rays are intersected? No. Okay, here. But it will intersected, but any point. rays extend but intersect chances. What will be the size of the image? It will be bigger. Yeah. So it is very bigger. So listen. When an object is placed at the focus, a real image is formed at infinity. A real image is formed, but at infinity it formed. Okay, at the place of infinity, 2F behind the 2F the image form out. It forms at infinity. Okay? Yes. So the size of the image is much larger than that of the object. So in this type, what happens? If we keep the object at F, that means at focus point, the principal focus, what happens? The image formed is much bigger. Okay? As here also it's a real image, inverted image. And what about the size of the image is much bigger. It's much bigger or much larger. Okay? Yes. Then the object placed between the principal focus and the F, that means a optical center. So what happens if we keep the object in between the optical center and the principal focus? So what happens here? So here this type, principal axis, the center of the optical center. Okay, yes. So this time the focus point, the principal focus here, principal focus, then the center of curvature. This is also the center of curvature, the C. Okay, it's C. Okay, if I keep the object in between the principal focus and the optical center, what happens this time? See here, when an object is placed between the principal focus and the optical center, a virtual image is formed. Okay, the size of the image is larger than that of the object. Okay, for example, if I keep the object near to the lens, say listen, one ray, which is falling to the focus. Okay, then another ray which is passing to the optical center. Okay, so here these two rays will not meet each other. They are diverged. So in the மாதிரி நம்ம ஆப்ஜெக்ட் ரொம்ப க்ளோஸ் ஆப்டிகல் சென்டருக்கு ரொம்ப பக்கத்துல வைக்கும்போது என்ன ஆகும்னா இந்த ஆப்ஜெக்ட்ல இருந்து வர ரேஸ் ஆஃப்டர் ரிஃப்ராக்ஷன் they will not intersect with each other. The refracted rays will not intersect with each other. Okay, அப்ப image எங்க ஃபார்ம் ஆகும்? So ரெண்டு rays refracted rays ரொம்ப intersect ஆகாத image form ஆகும். But where the image will form? See, if we extend these lines towards the backward, see if we the refracted rays is actually, if we extend the line backward, what happens? These two rays are meeting at the point. See here, the refracted ray are perpendicular. Okay, so here it forms. Okay, so where the image is formed at the same side of the object. Okay, see here. And what about the type of the image? The type of the image is, here the image is erect, it is not inverted. And what about the size? It's bigger than the object. Okay, and where it is formed? It forms at the same side of the object. Yeah, the same side of the object forms. Okay, so here the real and inverted image is formed behind the center of the curvature. Okay, so here this is also the real image. Okay, but this time it is not. Sorry. So when an object is placed in between principal focus and optical center, a virtual image is formed. Sorry, this is a virtual image. Is it? It's virtual image is formed. Where actually the image is not formed by the intersection of the refracted ray. Yeah, the refracted ray intersect another image. So this actually is a perception. Okay? Yes. If we extend the lines, the refracted lines backwards, okay, the backward lines are meeting at a point. Okay? There the image is formed. Okay? Yes. So that type of images are called virtual image. Okay? And then the size of the image is larger than the object. Larger than the object. Okay? Yes. So for this 6 cases we have seen. This, listen, keep the object. So what happens in different points? F1, F2, to F2 and to F2. To F1 and to F2. And this is O. Okay, the first case where we kept the object far away. Okay, if the object is far away from the lens. Okay, yes, if the object is at infinity. At infinity, where the image is formed, it is formed at the focus point. But what about the size of the image? It diminished. Okay, see the same object. The next case where I kept before beyond 2f, that means beyond the C, that means beyond center of curvature. That time what happened? That time what type of image we formed? Image we got? Yes, the real and inverted image is formed in this case. And what about the size of the image? It's small. It's smaller than the object. And next case what I did? What we did? We kept the object at 2f. If we keep the object at 2f, keep the object at 2f, where the image will form? At the 2f itself. Okay, and the size of the image is same. Okay? Yes. Okay? The next time, I kept the object in between the focus, in between the principal focus and the center of curvature. Here. So, in the object, image in the 2f1 beyond 2f1. And here the size of the image is bigger than the object. Okay? Next, what happens if I keep the object at f1? Okay, if I keep the object at f itself, focus point variable, what happens? The two objects are the converging, so the after refraction, the image is formed at infinity. Okay, the image after refraction, the refracted rays number diverge, converge out. So the converge at infinity time. Okay, at infinity distance. Okay, so the image is formed at infinity. Okay, we don't know where it formed, at infinity. So what about the size of the image? In this case, it's larger. It's larger. And what about if we keep the object very near to the base, in between the center of optical center and the focus? So this time what happens? This time we get the visual image. Okay, so this time we get the visual image. That means the image is formed at the same side of the object. Okay, the visual image we will get, and it is bigger than the object. Okay, the image is formed. The image form is actually bigger than the object. Okay, yes. So this is the image formation in the convex lens. Okay, convex lens for object image. So next we are going to see the applications of convex lenses. What are the applications of convex lenses? Convex lenses are used as camera lenses. Okay, they are used as magnifying lenses. So convex lenses is actually, they are magnifying lenses. They are used in making microscope. And also in the microscope we are using the convex lens and the telescope and in the slide projectors. Okay, to enlarge. They are used to correct the defect of vision called hypermetropia. So convex lenses are used to rectify the hypermetropia that we will learn in the following session. Next, refraction through a concave lens. Okay. Next, the refraction through concave lens. See, the same time as the object at infinity. Two cases we will discuss about only the two cases when the object is at infinity and the object anywhere on the principal axis at definite distance. Okay, so எங்க வச்சாலும் என்ன மாதிரியான object கிடைக்கும். Okay, see for example is the concave mirror, sorry, convex lens, the principal axis, the center, optical center of this lens, then again this side the principal focus f1 and the principal focus f2. Yeah, then the 2f1 and this side also. Okay, if I keep the object at infinity, okay, at infinity, again all the races are parallel, all the races are parallel. See, என்ன ஆப்ஜெக்ட் வந்து ரொம்ப தொலைவில் இருக்கும்போது வர races, incident ray எல்லாமே எப்படி இருக்கும், parallel to the principal axis. Okay, and they are get refracted, they are diverged. See, is it after it falls on this lens is refracted, is diverged. So the rays are பாத்தீங்கன்னா diverge ஆனவா இருக்கும் இல்லையா, converge னா ஒரு இடத்துல குவியும், diverge ஆனா ஒரு இடத்துல இருந்து விரிவடையும். Okay, is diverged, after it falls is diverged, after it falls is diverged. Okay, but where the image will form. Okay, nam sonna liya. So when the two refracted rays are intersect only, we can able to see the image. Is it? So here in this case of concave lens, where we can see the image. See, listen. If we extend the refracted rays in backwards, it converges at a point. Okay, so here we can see the object at F in the principal focus. The image is formed at the principal focus. And what about the size of the image here? The size of the image is much smaller. Okay, it's much smaller than the object. Next, object anywhere on the principal axis at a finite distance. See, for example, if I keep the object principal axis, concave lens, the optical center O, the f1 this side and the f2, then the 2f2, 2f1 and 2f2. Okay, the 2f2 otherwise known as center of curvature and the f is the principal focus. The f is the principal focus. Okay, yes. So this time in this case, so I am going to keep the object in between the 2f1 and the f1. What happens this time? The object, so one ray which is parallel to the principal axis and another ray which is going to the optical center. Okay, what happens this time? The optical center. upside down is erect image. Okay, see. The one ray is from backward. Clear? How the image is formed? Explain it clearly. See Z. O optical center, the principal axis. Okay. One ray is passing, which is parallel to the principal axis. One ray is passing to the optical center. Okay. After it's refracted, this ray is diverged and this ray is to the optical center. Okay. So what happens where the image will form? If we extend the refracted ray at the backward, where we focus ahead, and two rays, here the intersection of the two rays will make the image. Okay. அதே மாதிரி இங்க எக்ஸ்டெண்ட் பண்ணனும்னா இது எங்க மீட் பண்ணனும் இங்க தான் மீட் பண்ணனும் இல்லையா? Okay, so here the image will form. So what about the image? The size of the image is diminished. It's smaller than the object. Okay, so but as the distance between the object and the lens is decreased, the distance between the image and the lens also keeps decreasing further. The size of the image formed increases as the distance between the object and the lens decreases. So this is shown in the figure. See for example, so in the concave lenses, the image is erect image. Okay, it's actually virtual image. We are getting the virtual image. Okay, yes. See here, the image, the object which is at the place 1, where the image will form in the F itself. எல்லாமே எங்க F1 க்கு முன்னாடி தான் வரும். Okay. So image எங்க வெச்சாலும் object நம்ம the principal axis ல எங்க வெச்சாலும் எங்க கிடைக்கும் image is in between, it is actually within this F1 focus point க்கு முன்னாடி தான் கிடைக்கும். Okay, the image is actually this side. But the distance between the object and the lens is decreased. The distance between the object and the lens is decreased. The distance between the image and the lens also keeps decreasing. Okay, the distance between the lens and the distance between the image and the lens also increases. Okay, it's decreasing. So further, the size of the image formed increases as the distance between the object and the lenses decreases. Okay, yes. So what are the applications of concave lenses? The concave lenses are used as eye lens of Galilean telescope, and they are used in wide angle spy hole windows. In the spy hole windows we have the concave lenses. We use the concave lenses. Then they are used to correct the defect of vision called myopia, and the myopia defect is myopia defect is also corrected by using this concave lenses. Okay, so the myopia and hypermetropia we will learn in the next class. Okay, so these are about the refraction through the convex and concave lenses, and the remaining part we will learn in the next class.